Swayam Prabha. Digital India. Educated India.
Now, then we were looking at some general representations of linear circuits which can be used more widely. Okay, so we were in the middle of sort of generating an equivalent circuit for a complicated circuit. Okay, so in the meanwhile, if you have any questions about what we did in the previous class or anything before that, please go ahead. Any questions about things we were discussing in the previous class? Okay, so let me get back to what we were doing. Now, what we were looking to do was to take a circuit of this sort, which consists of linear elements and linear control sources, which are controlled by quantities inside. This is this network N, and then it is loaded by a current source Ix, which could be a current source or it could be the equivalent of any other load or complicated network that is connected. We know from substitution theorem that if we had some other network here, we could replace it by the current source that it is drawing. Okay. So now what we did was, this is a linear network, so superposition applies, and we can analyze this in 2 steps, okay, which is what I have shown here. Let me copy this stuff over. So I'll do a 2-step analysis of this. I have a number of independent sources inside, and I also have this independent current source Ix, which could be a current source or it could be a substitution for some other element, so some other load. Okay. So first I will deactivate the current source, that is I will set Ix equal to 0 and analyze this circuit, that is at these terminals 1, 1 prime, I will find the voltage Vx1. Okay. Next, I will set all the sources inside, all the independent sources inside to 0. So that is known as nulling the circuit. Then I will analyze the circuit with Ix alone. Okay, so Ix is active in this case. So clearly by superposition, in this case when everything is acting, that is when you have the load that is represented by Ix, plus when you have all the independent sources inside the circuit, you will get a certain value of Vx. And this Vx, which is the solution you are looking for, is nothing but Vx1 plus Vx2. Okay? What you calculate from this step by setting this Ix to 0, and then this step by setting all the independent sources in the circuit to 0, and that is nulling the circuit and finding the voltage. Okay? Is this part clear? Splitting up the circuit like this? Any questions about splitting up the circuit in this manner? That is, first I will activate all the current sources inside, deactivate this IX, then I will null this circuit and have only IX active. Okay, so let me just imagine that I have only one source inside. Okay. And one independent source outside, which is IX. So clearly, by superposition, what is the meaning of superposition? If you have a number of independent sources in a circuit, we can, and then let's say you want to find a certain quantity, let's say this Vx, okay, at these terminals 1, 1 prime, then what you can do is analyze the circuit with each independent source activated at a time. Okay, so if you have a number of independent sources, you set all the independent sources to 0 except one of them, you find the value of Vx from that one, and next you take the next source and set that one to a non-zero value and everything else to 0, then find the Vx from that. Do this for all independent sources, you will get a number of different values of Vx, and you add all of them up, that will be the value of Vx with all the sources active. Okay. So now you don't have to do it one by one. Let's say you had 5 independent sources. You could take 3 of them once and then 2 of them the other time, or 4 of them once and 1 of them the other time, and so on. Okay. So here what I will do is I will first deactivate this IX, which corresponds to the load, which can be substituting for the load, and find this voltage, and then I will null everything else, that is I null the circuit and find the value of Vx2 from this. Okay. I hope that is clear. Now one of the questions is that is it possible to find a current instead of that voltage? Yeah, it is very much possible. Okay, it's not a problem at all. Later you will see that. Okay, first of all, let me call this Vx, and then there is certain branch, and then that is IY or something. Okay. Now if this circuit is linear, then this Vx and Iy, any of these quantities can be found from superposition. Okay, that is any branch voltage or any branch current can be found from superposition. Okay, so that applies to any quantity that you would like to find. Now let me look at the first part of this, that is Vx1. Now you see that Vx1 is nothing but the voltage that appears across 1, 1 prime when it is open circuited. Okay. It's the open circuit voltage, or the voltage that appears across 1, 1 prime when it is externally open circuited. Okay. That is, no load is connected. Okay, that's the idea. Okay, So one part of this is the open circuit voltage. Now remember, what we are trying to do is, we have a very complicated circuit and only these terminals 1, 1 prime are accessible to us, and this may be connected to yet another circuit. Now what we would like to do is to have, instead of analyzing this complicated circuit n every time, we would like an equivalent representation of n that is simple. Okay, so that's our goal, that's what we are driving at. Because if you are not interested in the internal details of n, we have only this 1, 1 prime and this will be driving the other circuit. So we are only interested in what happens to this terminals 1, 1 prime and in the other circuit. We don't need to analyze all of n every time. Okay, that's the idea. Now that is the first piece of the puzzle, the open circuit voltage. Now the next part is with n being null, that is all independent sources inside n are set to 0, okay, and we have only a single independent source in the circuit. We have a single independent source Ix in the circuit, okay. So now we will have this Vx2. So my question is, please try to answer this. What is the general form of Vx2? What is the general form of Vx2? That is, we are now talking about a circuit which has only linear components and all the independent sources are set to 0. So we have a single independent source Ix. What I would like you to answer is, what will be the general form of Vx2? Okay, meaning how would it be related to Ix? Yeah, I think many of you are able to answer it. Vx2 will be proportional to Ix, and with the polarities given, it will be of the form minus Ix times some R, okay, where R is a property of this circuit. R is basically the resistance looking into the terminals 1, 1 prime, okay. Because we have a single independent source here, Ix, and then all the other sources are null, and all the other components are linear, so every quantity in this, every branch voltage and current will be just proportional to Ix, and that will apply to Vx2 also, okay. And with the sign that I have taken, okay, because Ix is flowing outwards, I will say Vx2 is minus Ix times R, okay, because the passive sign convention 1, 1 prime, if Ix would be flowing that way, then I would, if I were flowing that way, I would take V in that polarity. In this case, I and V are in the opposite polarity to this convention, so I will say it is minus Ix R, okay. And what is this R? It is the resistance, I will say, looking into 1, 1 prime with all independent sources set to 0, okay. So that's the resistance of the network N looking into the terminals 1, 1 prime. Okay. And this voltage Vx1 is the open circuit voltage. I could also call it VOC. Okay. Or let me call it VTH. Okay. The reason for this will become clear. This open circuit voltage is called VTH. What I do is I simply measure the voltage across 1, 1 prime with nothing connected to 1, 1 prime. Okay. And this R, I will call this RTH. Again, the region will become very clear. Okay. So now, so this quantity is called what I called VTH. Okay. The open circuit voltage, and then here this quantity will be minus Ix RTH, where RTH is the resistance looking into 1, 1 prime. So the total voltage Vx will be equal to VTH minus Ix RTH. Okay, where VTH is the open circuit voltage and RTH is the resistance looking into 1, 1 prime with all the independent sources set to 0. Okay, so this is the voltage that will be present when this network is connected to a load current of Ix. Okay. So this is Vx in the complete circuit. Now the network is active and the load current is connected to it, this Ix. Okay. Now because Vx is in this form, it's very easy to see that this can be generated by having a voltage source VTH and a resistance RTH in series with it. So if I connect the resistance Ix, the current source Ix here, you will very easily see that all of this Ix will flow through RTH. So the voltage drop across this is Ix RTH. Okay, and the voltage between these two terminals will be VTH minus Ix RTH. Okay, so the voltage here will be exactly the same as that one. Okay. So this entire thing here, this is terminal 1, 1 prime, the whatever is inside this red box is equivalent to the original complicated circuit N between the terminals 1, 1 prime. Okay, so it's only that is equivalent. Internal details of this we don't know. The internally here we have only a single voltage source and a single resistance. But as far as the terminals 1, 1 prime are concerned, the voltage across this and the current through this will be exactly same as in the original network N. Okay. Now this is regardless of what is connected to it, because we didn't make any assumptions about Ix. Okay. So Ix is some current which could be a current source or which could be a substitution for some other load. But whatever it is, this entire thing, which is a set of independent sources and linear elements, can be replaced by a voltage source VTH in series with a resistance RTH. And this particular representation probably some of you know this already. This is known as the Thevenin circuit or the Thevenin equivalent circuit of this part. Okay. So now, as I said earlier, if you are not interested in the internal details of this, so let's say you design a very complicated circuit with hundreds of resistors and control sources and many independent sources, and you want somebody else to use it, but you have only two terminals that are brought out, which is what they are going to use. So in that case, they don't need to know all the internal details of this. All you have to do is to give the Thevenin equivalent. You give the value of VTH and RTH. Because you know the internal details, you can calculate these things. But once this is done, as far as the terminals 1, 1 prime are concerned, this very simple representation and whatever stuff you have inside this are completely equivalent. Okay? And this, the idea that any circuit can be reduced to this is known as Thevenin's theorem. Okay, so any questions about this? What we did was we just used linearity of the circuit N and proved that it can be represented by a voltage source in series with the resistance. Okay, essentially we proved what is known as Thevenin's theorem. Okay, so any questions about the proof or the idea of Thevenin's theorem? There is a question on when we cascade two networks, is there any chance to change the voltage between the two networks? Actually, this question is not clear to me which voltage or what is being referred to. Okay, so I have to either draw a figure and email it to me, then I will discuss that. Okay, so I'm not clear about what is meant by cascading of two networks and what is the voltage between the two networks. So any other questions about this, Thevenin's theorem and its proof? Actually, the proof is quite simple. All we used was linearity. Okay. And any questions that you have, if you want to send something in detail, please use the forum, discussion forum for given for this course. Okay. On the NPTEL website. Okay. So the voltage VTH is the open circuit voltage across the two terminals, and RTH is resistance between the two terminals. So looking into the two terminals with independent voltage sources nulled. Okay. It appeared that because of some network problem, the connection broke, and also the audio and video went away for a while. I hope it is solved now. Are you able to hear me? If there is no audio, then again let me know. Okay, so as I'll repeat what I said, I was just saying that Thevenin's theorem says that if you have a two-terminal network with independent sources and linear elements inside, at the two terminals it can be equivalently represented by a series combination of a voltage source and a resistance. The voltage source is found by determining the voltage across the two terminals with nothing connected to them, and the resistance is found by nulling all the independent sources in the network and finding the resistance looking into the two terminals. Okay, so as I said, we will work out an example, and the example circuit I took was this very simple circuit. I have a 10 volt source, a 3 kilo ohm resistor in series with 7 kilo ohms, and these are the two terminals at which I want to find the Thevenin equivalent. This is very important. I mean, what is equivalent? When you say it's the Thevenin equivalent of a circuit, the Thevenin equivalent applies only to some two terminals specified. In this case, it's this 1 and 1 prime. Okay. So now my question is, what will be the Thevenin voltage across 1 1 prime in this circuit? Please try to answer this.